Working with electricity is dangerous. This video is an example of what we've done. Read the disclaimer carefully before you continue.
So, busy measuring and drilling holes where the panels will fit to the frame. Okay, so unfortunately the panels will fit at an angle on the flat roof to be able to face north. So I'm not 100% sure where I'll have supports to actually fit the frame to the roof. So I'm building the frame slightly bigger than necessary, and then as we fit the panels to it on the roof, I will figure out how I will support it to the roof structure. The roof that I'm fitting it on is a flat roof with steel trusses, so we can drill straight into the steel trusses, so that should give us some really good support. I'm also not fitting the panels standing upright. I'm going to fit them lying down, and the reason for that is I don't want to create a lot of wind resistance. So the higher they protrude from the roof, obviously the more wind it will catch. Now I'm trying to minimize the amount of wind that the panels need to deal with. Okay, we've basically bolted the 3 panels to the frame. We'll turn it around and see how we're going to fix it to the roof. And I've also installed, as you can see, 2 PVC conduits at the back of the panels through which the cables to the charge controllers will run. Okay, so we fitted the PV array on a set of supports to give it the right angle, and then tomorrow we're going to start with the wiring, so everything is nicely, neatly secured to the roof. 3 panels, all done. And Hendrik's busy crimping the panels to the wires that goes to the charge controllers. So you'll see we decided to crimp and not use the solar connectors. Once the crimp connection is made, he used some shrink tubing to make sure it's properly insulated and protected from water. Okay, final touches. Connected on the roof. As you can see, charge controllers are working. What's interesting is that all the little lights on the charge controllers are not the same, and there's various reasons for that. All the panels doesn't generate exactly the same amount of electricity, and it doesn't matter how well calibrated the charge controllers are, they won't measure exactly the same voltages and current. So as you can see on panel 1, that's not doing any work anymore. Panel 2 is working, and panel 3 is working, charging the batteries, but the charge controller on panel 1 decided that no, the batteries are full enough. Last little final touch on the side there, you can see there's a smoke detector. As I said earlier, batteries is a fire hazard, so it's always important to know when there's something wrong. So that concludes the PV installation. I've connected to the output of the PV installation, and as you can see there, it gives me without a load at the moment 26 volts. So the moment we put a load on, it will most probably fall to just over 24 volt. Okay, what remains to be done, but that will not be part of this video, would be the installation of the inverter and also a breaker box connecting to the devices in the house that will run off the PV system. This is not a grid-tied system, so it's completely standalone. So I've basically got two sets of wires in my house. There's certain devices that runs off the PV installation and others that will remain on mains. For instance, my stove and my oven, they will remain on council mains, and then my water heaters as a backup, so when there's not enough sun, will also remain on council mains. So the water installation basically is solar, but it's backed up by electricity. So if it's a cloudy day for a few days and we don't get enough sun, at least we will have hot water.